So this is like my take 3 on this because I'm trying to think of the best way to make this make sense to y'all. Nobody likes transformations, absolutely nobody. So the easiest way I think to do this is to write an equation. This is a parabola, so we're thinking ax minus h quantity squared plus k. So left 2 is going to be plus 2 inside, and then minus 4. And the slope here, by the way, is accounting by 1. Each block is a half, is to rise 1 and run 1. So it's an understood 1. This is what f of x is. Here's what g of x is. G of x is x minus 3 quantity squared plus 2. And its slope, if we travel 1 unit, is to run right 1 and fall 2, negative 2. Now, a couple of these things can be done pretty easy. Your order here is B, H, A, K. B is not something you're going to have to worry about, so H is going to happen first. What happened? We went from 2 to negative 3. So here's what I know. I lost 5 on the interior. H is easy. H is easy, okay? It's the A that's rough. A needs to be done separately off the side. To do A properly, you have to take what it is, negative 2, and you have to multiply it by the entire equation. So we distribute, and after applying A, we get negative 2 times x plus 2 quantity squared plus 8. All right, so interesting. When we do the negative 2 part, we get an equation that doesn't really look like this, does it? I end up at 2. So now I've got to start worrying about k, which if I have 8 and I need to become 2, I need to think 8 minus 6 is 2. So this is the full rule. And these can be quite challenging, but 8 minus 6 is 2. That's the full rule for this one. Transformations are difficult. There's no doubt about it. Number 9, a quadratic has a vertex at 4, negative 3. Determine the vertex of the quadratic after transformation f of x minus 10. This, by the way, would not be left 10, it would be right 10, and that is up 8. So right 10 from 4 is 14, negative 3 add 8 is 5. 10, the determined domain of x minus 4 over x squared minus 25. You're supposed to be factoring. And the big deal is that x squared minus 25 is not 0. There's 2 ways of doing this. You can do x minus 5 times x plus 5 is not 0, which is x is not 5, or x is not negative 5. Or you can shift the 25 over, but what I've found is most kids forget about the plus or minus symbol. That's the common error. So x is, in this case, not plus or minus 5. A couple ways of doing it. Preferably you factor. But anyways, the x minus 4 doesn't matter unless you're Hayden Burris. He'll worry about it. Find the domain of root of negative 3x plus 18. For the square root of anything, what's inside is greater than or equal to 0 unless it's in the denominator. So negative 3x plus 18 is greater than or equal to 0. We're going to subtract 18. Negative 3x is greater than or equal to negative 18. We're going to divide out the negativity, which is going to imply in any sign change, x is less than or equal to 6. That would be negative infinity all the way to 6 with a bracket on the 6 using interval notation. 12 is the difference quotient. This will probably be where I stop because the bell's about to ring for first period. Good news is this is more than I thought I'd get done. So I'm going to do this piece first. Every x I see becomes x plus h. I'm going to square it, so I'm going to write it twice. When I FOIL this guy, I've got an x squared plus an hx plus an hx. So that's plus 2hx. I actually like to write 2. Well, it doesn't really matter. Plus 2hx plus h squared. Still got a negative 5 out in front. Distributive property minus 2x minus 2h plus 3. Distribute the negative 5x squared minus 10hx minus 5h squared minus 2x minus 2h plus 3. Now I'm going to insert the rest of this thing. Take away f of x. So take away all of that. Notice I used a parentheses. And it's all sitting pretty over that h. Now look for cancellations, because there are a lot of cancellations. You have a negative 5x squared, and negative times a negative is positive, so gone, gone. You have a negative 2x, but it's going to be made positive by that. Gone, gone. These pieces always cancel. 3, take away 3, gone, gone. We have negative 10hx minus 5h squared minus 2h, all sitting pretty over an h. I get to cancel out the h there, the h there, the h there, and one of those. So I'm left with negative 10x minus 2 minus 5h. Oops, got the negative 10 there. And that's the difference quotient. Now, if you want to do the bonus, you just plug in a 3 right there, and you get rid of that guy. That's how you do the bonus. And that was the bell, which means I've got to teach class. So, till planning period. Later.